Hello everyone, we are Team 2 and this is our final presentation for our final design review. Our device follows the Hidden Power themed cart at the Franklin Institute, where we will answer questions such as how is electricity generated and how can you transfer mechanical energy into electrical energy. With that being said, our natural science topic is the conservation of energy, and our applied science topic is the transformation of mechanical energy into electrical energy, as well as the function of gear ratios and their impact on performance of the system. The final product design will consist of a 3-gear and chain crank-driven transmission attached to a simple generator. The input will be measured using torque and RPM meters, and the resulting values and calculated energy will be shown on simple gauges. The output voltage will be measured via a voltmeter, and the resulting value and calculated energy will also be displayed on a simple gauge. About half of the top of the device will be made of plexiglass in order to allow viewing of the internal functions, such as the gearing system. The other half will consist of a light array that changes based on the user input. The device will not require any user assembly and can be set up either by the teacher or students simply by placing the device on a stable, flat surface where it is accessible. The user will physically crank the device to see an instant output of a voltage readout, which is also displayed in converted energy units of joules. They can compare the electrical energy readout with the mechanical energy input reading at the crank. Through changing the gears, the user will be able to see either the changes to torque and RPM applied at the crank or changes to the output voltages depending on the demonstration technique. The concept of transformation of mechanical energy into electrical energy will be shown through the operation of the mechanical hand crank under different conditions of gear ratio or speed, which results in a corresponding electrical light display. The input mechanical energy will be recorded via torque and RPM sensors to calculate rotational energy and shown on a display at the crank, and the output electrical energy will be displayed in both volts and converted to joules. This product will also lend itself well to teaching the basic principles of conservation of energy, which will be taught through showing the amount of energy input into a single turn of the crank, then comparing this to the resulting amount of energy produced by this action, represented by volt and energy gauge and light display. The function of gear ratios can also be taught within the same device presentation through the explanation of the differences in energy output from a single turn at set speed of the crank as a result of the change in gear size. The difference in rate of turning of the generator drive gear as the gear ratio changes will also be visually evident. Crucial functionalities for the final device design are primarily centered around the overall objective for this device, which is to effectively teach the desired natural and applied sciences. The ability for students to be able to gather and record accurate input data will be imperative to the overall objective for the device. With this in mind, crucial functionalities that were identified include 1. The final product must have at least 3 working gears of different sizes, which output a measurably different amount of electricity from each other when either rotated at the same RPM or the same torque input level. 2. The user has the ability to produce equal amounts of input energy for each of the gearing options with the final device. 3. The values measured from the input and output must be displayed in a manner that directly represents energy. 4. There must be at least 3 LED lights connected in series which light up different amounts according to the gear that is being used, number of rotations held constant. And 5. The gauges accurately represent the amount of input mechanical energy and output electrical energy. Pictured here is the initial CAD design and final outcome of our prototype model. This prototype was designed to test the bicycle gear concept and ratios to determine the range of voltages that could be produced under specific operating conditions. It consists of a small 12-volt motor utilized to produce electricity and a 3-gear bicycle-inspired gearing design, all mounted with epoxy in a simple wood frame.
Our user input is this hand crank and also the variable speed drive here. You can see we have 3 different gears for 3 different speeds. But now I will show you the 2-to-1 ratio, the 30-tooth to 15th tooth, using a metronome to track my RPMs. The metronome is set at 80 beats per minute, so we're going to do 80 revolutions per minute. And here on the voltmeter, we have it in millivolts DC. And as you can see, at 80 RPM, we are doing roughly 188 millivolts. Sometimes we have a spike. And then quick gear shift. Here we unhook it, and then we we can slide this over so that the gears are always in line with each other. And now we're doing a 1.33 to 1 ratio at 80 RPMs. And again, for the 1 to 1 ratio, I slide it over, change the gear. And here I need a little idler pulley. Again, at 80 RPMs, doing roughly 80 millivolts, fluctuating a little bit.
Through this experimental method, we were able to successfully test the voltages that were produced at differing RPM and gear ratios. Based on the results, it has been determined that the large gear, currently located on the motor shaft, should be moved to the crankshaft, as it is currently producing half the energy it is capable of. Switching the gears will produce higher RPMs at the motor shaft and, as a result, more output voltage. Some of our observations were that the bicycle gears work well in the device. The device needs a higher gear ratio to produce more voltage. The voltage we were able to obtain varied between 20 and 100 millivolts of direct current. A motor with a lower rated RPM would function better, and in addition of a freewheel would allow the motor shaft to spin without the crank turning. This prototype requires a precisely turned shaft to reduce vibrations, and the connections between the shaft and motor requires improvement. And lastly, the larger gears should be on the handle shaft and the small gears on the motor shaft. The prototype shows that with some minor changes, the final product will meet the needs and specifications. Currently, the prototype is not drawing enough voltage to convey the concepts we would like to show. With these adjustments, the product will work as expected and will serve its purpose as an educational device. Furthermore, this device should continue development through EduRob. To summarize our presentation, I talked about how our device will be used to educate the end user in power generation and how the device demonstrates natural and applied science. We hope that students will find our device helpful in understanding these concepts, but most importantly, we hope that they have fun learning about it.